All right, so before the vacations and midterms, we were talking about the seepage through the soils, and we covered the basics of the seepage analysis, and we also discussed the Laplace equation and one and two dimensional flow solution through the graphical solution of the flow nets. So these are the course learning outcomes of the CV231. As you can see, so lecture 14 was about the understanding of fundamental concept. Lecture 15 was applying the principle of the soil mechanics to the seepage. And in today's lecture, we will analyze the relevance of the seepage to the civil engineering problems such as the uplift pressure on the hydraulic structure, the seepage rate through the sheet piles. So we will solve two numerical examples, and in our next lecture we will talk about the earth dam filter materials and the seepage through the body of the earth dam. So if I just review our midterm uh, syllabus, so were having the 7 chapters, okay, and we also covered few lecture related to the soil seepage. So, and then there are 3 more chapters which are left, which we one is the in situ state of stresses, then there is a stresses in the soil masses, added stresses, and the chapter 11 is the compressibility, which is almost equal to 2-3 chapters. So I already told you in your very first lecture that in your final exam, which are likely to be on campus, so there will be entire curriculum which I have taught you, that will be the part of your course in your final exam. So please try to cover up everything on daily basis. It will be a lot of syllabus once you will be on campus, okay, and I really want you to prepare on time. So in our previous lecture we talked about the calculation of the flow in the channel, and I told you, okay, for example, if this is a sheet pile, okay, so this is the upstream side and this is the downstream side, and there is a head on the upstream side which is 5.6 meter, and there is a head at the downstream side 2.2 meter. So delta H will be 5.6 minus 2.2, and if you want to calculate at this location, this, so today we are going to see how to use the equipotential drop to calculate the head at a particular location. So then we'll look these are known as the flow channels. Okay, this is 1, 2 and 3. So there are 3 flow channels, and it is assumed that in flow channel 1 the length and the width is same. So these are the almost equilinear square or the curvilinear squares. And the flow channel 2 is also a curvilinear square, but flow channel 3, it is a rectangular, or the length to width ratio is 0.38. So the total flow through this sheet pile is equal to flow through channel 1 plus flow through channel 2 plus flow through channel 3. And we also derive the two-dimensional flow equation, which is equal to the coefficient of permeability through one flow channel divided by number of equipotential drop multiplied by the head. So because both of first 2 channels are having the curvilinear squares, so that's why we are adding those, but the third is a rectangular, so we multiply with the n, and n is here 0.38. So if you want to calculate the total flow, this will be the summation of all of these flow through channel 1, channel 2 and channel 3. So the total flow rate or the seepage rate will be equal to 1 plus 1 plus 0.38 will be 2.38. K is the coefficient of permeability, and here it is assumed that the horizontal and the vertical direction of the permeability coefficient in the horizontal and vertical directions are same, and n subscript d is the equipotential drop. So I requested all of you to review my lecture 14 and 15 before attempting this lecture, but I expect that you may have looked into the slides. Anyway, so this was just an overview of the previous lecture. This is a practical example in which there is a row of the sheet pile in out of plane direction. This is the sheet pile, okay. So a flow net is drawn and it is given to you, okay, in a permeable soil layer. So the flow net is impermeable because this is impermeable and the water cannot flow, so there cannot be the flow channels or the flow lines. And it is also given to you that horizontal and the vertical coefficient of permeability are same, and the value is 5 multiplied by 10 to raise power minus 3 centimeter per second. And you are asked that how high above the ground surface the water will rise if the piezometer are placed at A and B. So it says that if you install a piezometer at this location, what would be the water head? Or if you install piezometer at this location, what would be the pressure head? So if we want to calculate the pressure head or the level of the water in the piezometer at any location on the flow net, we need to use the formula of the equipotential drop. So let's see. From the figure you can see how many equipotential drops are there. One. So this is suppose 1, 2, 3, 4, 5, 6. It means total equipotential drops, number of the drops are 6. Okay, and you are given water head at the upstream side is 5.6 meter. Okay, at the downstream side is 2.2 meter. Okay, now the head loss at each equipotential drop. So for example, at the first equipotential drop, how much would be the head loss? Let us calculate. So delta H will be equal to the head difference at the upstream and downstream side divided by number of the equipotential drop. So which is equal to 0.567 meter. So this is the head loss of one equipotential drop, and we have assumed that these will be equal. Okay, so at point A we need to know how many equipotential drops are at point A. There is only one equipotential drop, so it means total head, which is 5.6 on the upstream side, sorry, so the head at the upstream side minus delta H, which is the head loss at one equipotential drop multiplied by the ND. And how many number of the equipotential drops are there at point A? Only one. So that's why 5.6 minus 0.567 is 5.033. Now let's see at point B. So 1, 2, 3, 4, 5. So at point B we have 5 number of the equipotential drop. It means if we install a piezometer at point B, then it will be 5.6 minus 5 multiplied by delta H. So see, 5.6 upstream head at the upstream side minus 5 are the number of the equipotential drop at location B multiplied by 0.567 is 2.765. So if there is any question how we calculated the head at point A and point B, or how we calculated how much water will rise if we install a piezometer at point A and point B. So let me ask a question. Jihad?
Yes, sir.
So please see this cursor. Okay, so let me tell you the location. So Jihad, can you tell me what would be the if I install a piezometer at this green point, how much water will rise in that piezometer? Okay, Mansoor.
सर यहाँ पर हम लोग 2 मल्टीप्लाई करेंगे 5.6
All right.
माइनस 2 मल्टीप्लाई बाय 0.567.
Okay, so let me ask some other student, Mansoor.
Yes, sir.
Can you tell me कि if I install a piezometer at this location जहाँ पे ये मैंने green point draw किया है तो क्या होगा?
सर यहाँ पे आई थिंक 5.6 होगा सर.
Okay, so let us ask Mehran.
सर ये ग्राउंड सरफेस डेटा में तो यहाँ पे कुछ जीरो आएगा.
No, 5.6 होगा. Mansoor is right. So if you install a piezometer at this location, then there will be the head 5.6 meter. Okay, so because from ground surface the water level is on the upstream side is 5.6 meter and there is no drop, equipotential drop. Anyways, so let me ask some other student. Fahad.
Yes, sir.
So can you see this location?
जी sir.
If I install a piezometer at this location, how much water will rise?
सर यहाँ जो लिखा हुआ है सर इसके ऊपर ये 2.2 है आई गेस यही होगा सर.
ओके, और अगर ये 2.2 ना गिवन होता तो?
सर तो पर मुझे
सर,
ये
मैं बता दूं?
ड्रॉप्स काउंट करने होते 1 2 3 4 5 6 फिर 6 हम मल्टीप्लाई करते हो उसके बराबर.
Sir, it will be 5.6 minus 6 into 0.567.
Very good. Okay, thank you very much. So I believe that every one of you is able to calculate the head at any location on given flow net of dam, sheet pile, weir. So this is same. Okay, anyways, so let's see the next part. Part 2 is the total rate of seepage through the permeable layer per unit length. So you have to calculate the total rate of the seepage. कौन बताएगा total rate of seepage का? How many channels are there? There are three channels. Channel 1, channel 2, channel 3. So in my previous lecture I told you that if you see for channel 1 the L by B ratio or the N is 1. Okay, B N is equal to B by L. Okay, B by, so you can review my previous lecture by L. Anyways, and 1 का क्या physical meaning है मेहरान? If I say कि flow channel 1 has L over B is equal to 1 तो इसका क्या physical meaning है?
सर ये curvilinear square है मतलब length और
Okay,
width
good.
बराबर.
This means that these are assumed to be curvilinear square. So for flow channel 2, this is 1. For flow channel 3, this is 0.38. N की value 0.38 है. Anyways, so the flow rate, total flow rate, if I add, this would be the formula, and how I came up with this formula, this has been explained in my previous lecture and also I revised in my previous slide. This is equal to 2.38 kH divided by ND. And please note, this solution is only applicable where horizontal and the vertical coefficient of permeability is same. If this is different, you have to consider different calculations, which is beyond the curriculum of this subject. Anyways, so 2.38 K is the coefficient of the permeability which is given to you. Okay, H is the head difference between upstream and downstream sides. So 5.6 minus 2.2 divided by number of equipotential drops 6. So I already told you that there are six number of equipotential drops. Okay, so this much meter cube per second per meter out of plane there will be the rate of the seepage. So again, please make sure that you understand the concept of this value of n and you understand this from my previous lecture, then only you will be able to, because this is not necessary that I will give you this same example in your exam. Okay, so the concept will remain same but the example or the question can change. Any question related to this slide? So Mansoor, can you please revise this slide?
यस सर. सर हमने इसमें जो है ना सर टोटल रेट ऑफ सीपेज फाइंड किया. तो वो हमारे
ठीक।
पास बराबर है Q1 प्लस Q2 प्लस Q3। Q1 और Q2 जो है वो स्क्वायर है, तो स्क्वायर के लिए हमने वो जो B और L है वो 1 के बराबर है, तो हमने 1 ले लिया। और जो L रेक्टेंगल के लिए L और B है वो हमारे पास B और L जो 0.38 है, 3.8 लिया। फिर हमने K की वैल्यू पुट किया, और जो हेड लॉस है 5.6 माइनस 2.2 वो पुट किया। उसके बाद जो नंबर ऑफ पोटेंशियल है वो हमने पुट किया। तो हमारे पास जो टोटल रेट ऑफ सीपेज है वो हमारे पास है।
Okay. Okay, good. So 2019 461 461, आप अपना अनम्यूट करो माइक। Who is 461?
मुताहिर सर।
So he is not attending lecture, right? So he is just in. Okay, I noted down his name. So who is 446? 461, 446. Okay. 421.
Yes, sir.
Okay, so 421, what is your name?
Namir.
नमीर, क्या आप ये बताओगे कि ये 2.2 क्या है बेसिकली?
2.2.
हाँ,
सॉरी सर, मेरे इस तरफ ध्यान नहीं था सर। मैं असल में
ओके
नेट
ओके
बहुत स्लो है, मैं बार बार डिस्कनेक्ट हो रहा हूँ, फिर आ रहा हूँ।
ओके। सो हु इज 338? 338. Okay, 338. 286. 073. 063.
यस सर।
क्या नाम है आपका?
अली सर।
जी,
अली।
ओके। आप ये बताओ कि ये 2.38 कैसे आया है हमारे पास?
सर ये जो हमारे पास Q2 और Q, आपने जो टोटल रेट ऑफ सीपेज इक्वेशन जब निकाली थी, ये वहां से आया था 2.38।
ये 0.38 कहाँ से आया है? चलो ये बता दो। 2 तो चलो ठीक है, तो ये 2.38 क्यों है? ये 2.4 क्यों नहीं है?
तो ये पिछले लाइक
Okay, all right. Okay, so let us solve the third part, which is you have to calculate the average hydraulic gradient at point C. So this is point C. You can see कि ये जो flow, ये जो line है और ये line है, okay, इसके दरमियान यहाँ पे एक point C है. This is point C. And the distance, so we have drawn a point, जो ये वाला लाइन है, इस लाइन का जो डिस्टेंस है, स्केल आप लेंगे। आपको जब ये फ्लो नेट गिवन होंगे तो यू मस्ट ब्रिंग स्केल इन एग्जाम, ओके, जो स्केल जिससे आप, सो यू कैन मेजर के ये जो लाइन है ये कितने सेंटीमीटर या इंच के बराबर है, ओके, देन यू विल मेजर दिस लाइन and then you can come up कि ये 4.1 मीटर के बराबर है ये डिस्टेंस. So you this is very basics in your matriculation. You may have learn how to read the scale on a paper. Okay, so ये 4.1 मीटर आपको इधर given है और ये given नहीं भी हो सकता. Okay, then you have to calculate this by your own self using this scale value. All right, so let's see how to calculate the I. Who will tell me I का क्या फार्मूला है other than Fahad and Mehran के अलावा और मंसूर के अलावा? I किसके बराबर?
सर, I is equals to delta H over L, मतलब
Okay,
कि
good.
head loss over distance between 2 points.
Okay, so आपका नाम क्या है?
So Zain Tariq.
Okay, Zain. So Zain, if this is C point, okay, so if we want to calculate, so this is the path, okay, so delta L is known to us by scale. हमने measure कर लिया कि ये दो flow lines के दरमियान 4.1 equipotential lines के दरमियान 4.1 मीटर डिस्टेंस है. तो L तो हमारे पास आ गया 4.1 मीटर. So ये delta H, it means that we have to install the piezometer at this location and at this location, and we will calculate the head at C, and we will calculate the head at over here, and then we will take the we will deduct both of these.
Distance.
That will be delta H. So let's see how they have calculated. Okay, but it's not like that. Okay, it is your total head loss जो आपका हो रहा है. ओके, और इट इज अज्यूम्ड कि जो हेड लॉस है, सो दिस इट मींस कि ये वाला जो डेल्टा एच है, दिस इज इक्वल टू H1 माइनस H2 डिवाइडेड बाय नंबर ऑफ द इक्विपोटेंशियल ड्रॉप्स. सो अगर आपने किसी भी जगह पे कैलकुलेट करना है तो यू हैव टू जस्ट कैलकुलेट द डिस्टेंस बिटवीन टू फ्लो इक्विपोटेंशियल लाइन. ठीक है, सो एवरेज लेंथ ऑफ द फ्लो बिटवीन D एंड E, तो उसने यहाँ पे एक E पॉइंट मार्क किया है, एक D पॉइंट मार्क किया है, और ये डेल्टा H क्या है जो हमने पीछे कैलकुलेट किया है स्टेप 1 में, विच इज इक्वल टू फॉर एग्जांपल 5.6 माइनस 2.2 डिवाइडेड बाय नंबर ऑफ द इक्विपोटेंशियल ड्रॉप्स आर 6. एंड आप इस तरह भी कैलकुलेट करके देखो, आई की ये वैल्यू आती है, और जो मैंने आपको मेथड बताया है कि यू कैलकुलेट what we call is the head at this point and head at this point, and then you divide this distance, and let's see कि क्या difference आता है, and then we can talk in our next lecture. Okay,
सर सेम आता है सर, मैंने
बात आपको
कैलकुलेट कर
समझ
लिया
आई?
सर, मैंने कैलकुलेट कर लिया, सेम आता है सर.
सेम आता है, लेकिन फाहद आई थिंक दिस इज मोर कन्विंसिंग कि हम यहाँ पे हेड कैलकुलेट करें फिर यहाँ पे करें, राइट?
ये सर हुआ बेस है सर, क्योंकि इक्विपोटेंशियल है तो वो सेम ही होगा सर, हेड डिफरेंस बिटवीन टू.
Okay, that makes sense. So Fahd is really smart, and he has said that because it's an equipotential line, so it will result in same. If these are not equipotential line, then definitely we have to consider both different heads. Anyways, thank you very much for your answer. So this was the problem in which we calculated practically the rate of the seepage, the head at any location, and the average hydraulic gradient at any given location using the example of sheet pile. Now there is another example related to the dam. So this is a concrete dam, ये जो आपको नजर आ रहा है, okay, this is a concrete dam. Now this concrete dam is basically resting on a soil which is basically silty sand stratum. So this is permeable layer, ये एक permeable layer है, okay, A to G. Then there is impervious layer of clay, so we are not going to consider the flow nets in clay. Okay, so it says के the reservoir के अंदर जो आपका head है वो 10 मीटर है. Okay, and it also give you value between B to C. ये वाली value कितनी है? 2.4. Why this is important? Because this is your datum. Okay, so you need to know okay, what is the pressure head at A plus 10, pressure head at C minus 2.4. Okay, और ये उन्होंने एक sheet pile install की हुई है below the on the upstream side of the dam, ताकि ये जो seepage path है ये long हो जाए. Okay, anyways, so this is the downstream side, and the length of the dam weir is 30.6 meter, and the coefficient of the permeability of the silty sand stratum is 2 multiplied by 10 to raise power minus 4 centimeter per second, and you are given 20.3 meter is the depth of the silty sand stratum, and you are also given these flow lines. ये आपको complete problem given होगा, suppose. Okay, so whenever you are given any problem in exam or in quiz, you will be given the flow nets and problem statement and the geometry, the coefficient of the permeability, the thickness of the strata, the water heads. Okay, and you must be able to calculate the. So the part A is you have to calculate the flow rate. The part B is you have to calculate and draw the pore pressure distribution at the base of the dam. Okay, and part C is you have to calculate the uplift force. So you can see how you learn the basics of the permeability then you learn the flow net seepage, और फिर flow net seepage के concept से आपने you learned how to calculate the number of the equipotential drop, how to calculate the water pressure head at any location, and now you are going to apply that to a dam. Okay, so let's see how to calculate the discharge. So as I already told you, okay, because on the upstream side there is 10 meter, on downstream side the datum is 0, so it means the head loss delta H is 10 meter. Okay, so this is the discharge formula, which is Q is equal to coefficient of the permeability of the permeable stratum, which is given to you, delta H 10 minus 0, okay, upstream minus downstream, head differences. NF is number of the flow channel, ND is the number of the equipotential drop. So let me ask Bisharat 104. Okay, so 238. 540, 552,
Yes, sir. Yes, sir.
5. Who is 552?
Yes, sir. It's me, Zain
Okay,
Tariq.
not Zen. Okay, no, not Zen. Okay, so 013. Who is 013? 045, 063.
Yes,
What is your name, 063?
Sir Ali.
Can you unmute yourself?
सर मेरा नाम अली है.
Okay, Ali. आपको ये समझ आ रहे हैं प्रॉब्लम, या मैं ना पूछूं क्वेश्चन?
सर आपका पिछला लेक्चर नहीं अभी देखा, जो लास्ट मंथ था ना.
All right.
अभी रहने में.
Okay, Mehran, can you tell me how many number of the flow channels are there in this flow net?
4, sir.
Okay, and Zan, can you tell me how many number of the equipotential drop and D are there, and subscript D?
Sir, 6. 6.
Okay, Fahad,
सर 13 है आई गेस. 1 2 3 4 5 6 7 8
Mehran,
9 10 11
14 is 14.
14 सर 14 है.
14 है. Okay, so I think there is nothing difficult. So these are the number of the flow channel 1 2 3 4, okay, which are highlighted by the red outlined circles, and these are the number of the equipotential drops, which are 14. Okay, you are just going to insert the values and simple calculation you can
Excuse me,
calculate.
sir.
Yes.
सर ये जो एनडी हमें सिर्फ वो जो जूम किया हुआ है उसमें से नहीं से निकालने, मतलब कि पूरी डायग्राम में से निकालने नंबर ऑफ इक्विपोटेंशियल
हाँ
ड्रॉप्स.
पूरी डायग्राम में से डालने निकालने.
अच्छा सर. ओके सर.
अच्छा, okay, so all right. Anyways, ये आप किसी भी फ्लो चैनल में निकालेंगे ना तो नंबर ऑफ इक्विपोटेंशियल ड्रॉप यही आएंगे. ठीक है, ये जिसने क्वेश्चन किया था. ओके,
ओके सर. ओके.
all right. Now, so part A and part B is solved. So let's see next, which is extremely important, is to find the pore pressure under the base of the dam. Means this will help us to calculate the uplift. Okay. So you know what is the unit weight of the water? It is already known to you. If you know that, if you multiply, so, oh, where is the cursor? Okay, so U is equal to gamma W, which is the unit weight of the density of the water, times H is the head of the water. So if you want to calculate the pressure at this point, it means pore water pressure, how much water will insert due to the seepage in this soil, the water will insert uplift pressure like this. Okay, इस तरह ऊपर ऐसे एक uplift pressure लगेगा इसके ऊपर. Okay, like this. So अगर आप यहाँ पे वैल्यू कैलकुलेट करना चाहते हैं तो इट मीन्स कि यू नीड टू नो द हेड ऑफ द वाटर एट दिस लोकेशन. अब यहाँ पे दो तरह के वाटर हेड्स हैं, एक सीपेज की वजह से हेड है और दूसरा डेटम का भी हेड है जिसे हम कहते हैं एलिवेशन हेड. ओके, सो लेट मी टेल यू कि व्हाट डज दैट मीन. दिस इज द डेटम. ओके, this is 30.6 meter. I already have shown you in previous geometry. This is 2.4 meter. This one, this height is 2.4 meter. From datum, this point is located as 2.4 meter because this is basically the elevation head. The pressure water head at the upstream side is 10 meter. Okay, so if we want to calculate the head loss at each equipotential drop, it means, sorry, we have to divide this entire length of the base of the dam into equal number of intervals. Okay, so if I divide into 10 intervals, so it means 30.6 divided by 10 to 3.06. So it means कि ये पहला मैंने एक इंटरवल बनाया है जहाँ पे मैं प्रेशर कैलकुलेट करूँगा पानी का. ओके, ये दूसरा बनाया है, देन सो ऑन. सो देयर आर 10. हमने इस बेस को जो कि 30.6 थी इस डैम की, उसको मैंने स्मॉल पोर्शन में डिवाइड कर दिया और ईच जो सेगमेंट है या इंटरवल है दैट इज 3.06 मीटर. ओके, यू कैन हैव 12 इंटरवल, यू कैन हैव 14 interval, you can have 8 interval. More the intervals are, the accurate will be the answer. And if I want to calculate the head loss at each equipotential drop, it means that the total head difference at the upstream and downstream is 10 minus 0. Okay, because this is 0 at this location and this is 10. Divided by number of equipotential drop, which were in previous slide Zain and Fahad already told us are Mehran 14. So this much head loss will be happening or occurring at every equipotential drop, 0.714 meter. Now, if you want to calculate the pressure head at any location on this flow net is equal to delta H, which is the total head difference, minus ND, which is the number of the equipotential drop जहाँ पे आप calculate करना चाहते हैं, multiplied by delta H. delta H है each equipotential drop जो भी हमने calculate की है, और HZ is basically the what we call is the elevation head. Okay, so I will show you practically के how you are going to solve. So ये जो मैंने एक स्मॉल ये जो सेगमेंट बनाया, ये 30.6 को मैंने 10 सेगमेंट्स में डिवाइड किया, तो यहाँ पे 0 है, दिस इज 0. ओके, एंड दिस इज 3.06. सो यू कैन सी दिस इज 0, दिस इज 3.06, देन नेक्स्ट पॉइंट विल बी 6.12. नेक्स्ट करते करते आप 30.6 पे चले जाएंगे. No, you have to calculate the number of the equipotential drop up to this location, 0 location. ये वाला जो coordinate है. So let's see. ये 1, 2, 3, 4, 5. Okay. So there are, if this is the location, you can say there are 5 equipotential drop for this particular location. So that's why I have this value of 5. Now my next coordinate is ये जो मेरा segment था, ये जो 3.06 का, ये 0 location थी और ये 3.06 location थी. Okay, so then I have to calculate ND at the 3.06. So one more equipotential drop. So that's why there is 6. Okay, so if I show you next, it is half, so that's why you are only counting the half. If it is 2/3, you have to only count the 2/3. And at the 30.06 at this location, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's why you are having 12. Okay. So now if you want to calculate n subscript d delta h हमने already जो head loss at each equipotential drop we already calculate. So you need only to multiply with the number of equipotential drop. So 6 multiplied by 0.714. Okay, 0.714. So you have calculated this term. Then HZ is basically the elevation head. So in very first lecture of the seepage analysis, I told you how to calculate the head loss, elevation head, energy heads. Okay, so you can see that this is the datum, and this location, the base of the dam is basically 2.4 meter below the datum. So the elevation head is minus 2.4, minus 2.4. It will remain same for the entire length of the dam. Now HP, if you want to calculate, you have to use this equation. Delta H you already know, okay, minus ND. So delta H की क्या वैल्यू होगी मेहरान?
ये स्मॉल डेल्टा एच सर,
No, capital delta H.
इसकी जो 10 है ना,
Okay, 10. गुड. सो 10 माइनस 0 होगी, ठीक है. सो अगर आपने इस लोकेशन पे कैलकुलेट करना है तो दिस इज 0 माइनस 2 पॉइंट, तो माइनस माइनस प्लस यू कैन कैलकुलेट एच पी. सो जब आपके पास एच पी आ जाएगा, प्रेशर हेड एट दिस लोकेशन यहाँ पे आ जाएगा, तो यू विल मल्टीप्लाई इट विद द यूनिट वेट ऑफ द वाटर एंड यू कैन कैलकुलेट द पोर वाटर प्रेशर. सो दिस इज गैमा डब्ल्यू, unit weight of the water multiplied by the HP. So this is how you are going to calculate the entire. So this, let me show you the calculations over here.
एक्सक्यूज
In
मी
a
सर.
simplified. Let me complete this slide and then you can ask a question. Okay. Okay. So you can see कि ये x क्या है, is the horizontal distance. For example, ये एक first है जिसका 0 और 3.0306. So then you will add and you will come to the end of the, okay, then number of the equipotential drop you can calculate. Okay, these are calculated. Then you multiplied number of equipotential drop with the head loss at each equipotential drop delta H and you came up with this value. Then HZ is the elevation head. Then HP equation is equal to delta H minus ND delta H minus SZ. So every value you already have in this table you are going to calculate. You are going to multiply the pressure head with the unit weight of the water and you will get the pore water pressure at that particular location. Then you will plot a graph. So you can see okay, this is the graph, this is 0, this is 30.6. Then you will simply plot the values of the pressure. So this is the uplift pressure of the water. Okay, ये uplift pressure of the water है. Now you can ask me question please, जो पूछना चाह रहे स्टूडेंट.
सर ये पिछली स्लाइड में कर.
ओके मैं जा रहा हूँ, एक मिनट प्लीज. ओके यस.
सर ये जीरो लोकेशन पर ये ND5 किस तरह है सर? 4 नहीं होगा ये शीट पाइल तक?
Okay. So,
Yes, sir. Yes, sir.
Okay, I agree. So if you want to calculate 4, you can calculate 4 और 5 को इतना difference नहीं है, कोई 5.6 भी इसे रख सकता है. मतलब to cut it short, you know the procedure मेहरान.
सही है सर.
ठीक है.
सही है सर. मतलब
So you can use 4 value. लेकिन ये नहीं हो सकता कि आप यहाँ पे 2 लिखो, right? 4, 5 या 5.66. मतलब there can be slight difference because this is a graphical method.
ओके सर. सही.
Okay, yes. Another question. Okay. All right. So any question related to this plot कि ये हमने डैम की जो बेस है उसके नीचे अपलिफ्ट की प्रोफाइल कैसे बनाई है? So Fahad, can you tell me how I developed on y-axis u and x-axis 0 to 30.06? ये क्या है 30.06, क्या 0 है, ये क्या है 82.3?
सॉरी सर, मुझे क्वेश्चन की समझ नहीं आई।
अच्छा, आप ये बता सकते हो कि ये 0 to 30 पॉइंट ये क्यों है, मतलब ये वैल्यू एक्स एक्सिस पे, ये जो
सर
ग्राफ
ये डैम का जो बेस है उसे हमने सर 10 इंटरवल में डिवाइड कर लिया है ताकि हमें इजीली मतलब कैलकुलेशन उसकी इजी हो जाए। और
ओके।
यहाँ
और ये क्या वैल्यू शो कर रही है, ये कहाँ से आई है वैल्यू 80?
सर ये जब हमने फाइनल कैलकुलेशन की हुई है उससे आई है सर।
So this is the pore water pressure. So you plotted this axis, this, ये और ये आपने प्लॉट किए हैं। ओके, सो दिस इज द पोर प्रेशर डिस्ट्रीब्यूशन। ओके, ये वो है। अब आपने बीम सॉल्व किए हैं तो आप लोगों ने ये देखा होगा कि अगर सॉरी ओके अगर ये एक बीम है, ओके, सो सपोज दिस इज अ कैंटिलीवर बीम और उसके ऊपर यूं एक ट्रायंगुलर लोड लग रहा है सपोज, ओके, यूवीएल, यूनिफॉर्मली वेरिंग लोड लग रहा है। तो आप इसका क्या कैलकुलेट करते थे? आप इसकी, अगर मैं कहूं कि इसको आप फोर्स के अंदर कन्वर्ट करो तो वो आप कहते थे कि इज इक्वल टू द एरिया ऑफ द ट्राइंगल। और अगर मैं कहूं कि पॉइंट ऑफ एप्लीकेशन क्या है फ्रॉम द फिक्स्ड एंड, तो यू विल से 1/3 ऑफ द लेंथ ऑफ द बीम, राइट? सो इसका मतलब है कि एक है टोटल फोर्स, यानी कि एक टोटल अप थ्रस्ट फोर्स है, अपलिफ्ट फोर्स, और दूसरी उसका पॉइंट ऑफ एप्लीकेशन है। सो यू कैन कैलकुलेट पॉइंट ऑफ एप्लीकेशन। फॉर एग्जांपल आप इसका और इसका ये रेक्टेंगल, इसको ट्राइंगल अज्यूम करके, एनीवेज these are the things you can figure out yourself. So let's see how to calculate the uplift force. तो uplift force ये एक trapezoidal figure है, okay? Maybe in surveying you have calculated the area of the trapezoidal using the Simpson rule. किसी ने Simpson rule use किया?
यस सर।
जी
यस सर, यस
जी
सर।
सर किया हुआ है सर।
Okay, so who would like to explain this Simpson rule? ये कैसे implement होगा?
सर उसका ये होता है कि जो आपके पास इनिशियल वैल्यू होती है प्लस लास्ट वाली, और फिर +2 मल्टीप्लाई बाय नंबर ऑफ ऑर्ड्स जो होते हैं ना हमारे पास एरियाज से जो होते हैं ऑफसेट्स होते हैं, +4 मल्टीप्लाई बाय इवन नंबर ऑफ ऑफसेट जो होते हैं।
और ये डेल्टा एक्स क्या है फिर?
ये
कॉमन
चेंज
डिस्टेंस है
होता है
सर,
इसके अंदर जो है ना।
कॉमन
ये
डिस्टेंस है सर,
इंटरवल और
कॉमन
हमारे
डिस्टेंस।
इंटरवल की क्या वैल्यू है इधर?
सर डेल्टा एक्सिस में 3.06 होगा।
5
Very
है
good.
सर।
Okay, good. So because all of you already know the Simpson rule, so this delta x is the interval in which I divided the entire base, which is 3.06. Okay. Then this is, as someone told, what is your name who explained the Simpson rule?
सर अली।
Ali. Okay, Ali is. So this is the first and the last value as Ali told us. Okay, and this is first, this is last. Then there are even values, sorry, odd values. So this
सर
is
और
odd value 1, 2, 3, 4. Okay, then there are even values multiplied by 4, and this is the total uplift thrust which will act. Now what would be the point of application? You have to Google it by yourself. Okay, but I believe this is very simple to calculate. This is your own task. I can give it in exam. Okay, so but in case you are failed to find the solution for that, you can simply send me an email or message on team. I will answer your question. Any question related to this problem?
सर आप एग्जाम में जब ये क्वेश्चन देंगे तो ये टेबल भी साथ होगा कि नहीं?
ये टेबल नहीं साथ होगा। ये टेबल क्यों दूंगा मैं एग्जाम में? ये
नहीं,
टेबल तो
मतलब
आपने
ये नहीं
गलत कर।
सर, फिर हमने इंटरवल्स खुद लेने होंगे।
Exactly, you have to divide it into interval by your own self. ठीक है?
ओके सर।
Please do some practice, solve this numerical, draw everything on graph, because the mid exam is not very good, because no one, there are very few students जिन्होंने plot किया है, graph लिया है, scale लिया है, so you will be having a very hard time in your finals. So I really want every one of you to solve, learn concept, because this is not likely that this example same problem will come in your exam. Okay, there will be some tricky, and the exam may not be the online exam, so you have to be on campus. Anyways, if there is any question, please let me know. Mehran, is it clear?
Yes, sir. Clear, sir.
Okay. So thank you very much and have a good day.
एक्सक्यूज मी सर
Yes.
सर आपने अभी बताया ना कि जो है ना मिड्स एग्जाम के अंदर आपको टेबल वगैरह जो है ना वो अंदर इंक्लूड नहीं थे सर आपको अलहदा से मेल कर दी थी कि जो है ना उसके अंदर याद नहीं था रहा लेकिन आपको भेज दिए थे वो
Your question is not related to this lecture, right?
यस सर
Okay. All right. Okay, ji. Have a good day.
एक्सक्यूज मी सर
Yes.
सर मेरा क्वेश्चन है सर कि हम जब एग्जाम में अब इस तरह आपने कहा था यहाँ पे कि ग्राफ पेपर आपने मतलब खुद लाने और उस पर ड्रा करना है ना जब ऑनलाइन एग्जाम था